All right. Good afternoon, folks. Appreciate people joining. And as people start to get into the room, I will kind of get us going here, kicked off a bit. And yeah, thank you very much for joining this AMA. And you'll see a poll pop up on your screen here, kind of asking a little bit about what you're looking to get out of it. So we'll see if we can answer some of those questions. As we are going along during our Ask Mayfield Anything, we try and keep this very conversational. So there is a Q&A function in the Zoom meeting. So we ask if you want to pose a question to the panel. By all means, we encourage it. We want to see what those questions are, be able to answer those really and as much as we can in real time. So I will keep an eye on that and kind of pepper those questions in as they're coming along. And then when you registered, you had an option of doing some question or sending some questions in. And we had a few questions that we want to make sure that we're covering as well. So thank you to those that submitted those. Really helped to kind of make sure that we gear the conversation properly. So thanks very much. Today, we're going to be talking about microgrid financing economics. And so we'll jump right into that. And first off, I want to just do a quick introduction for myself and the company, and then our panelists, just to help set the stage for it. So for those of you who may not know me, my name is Ryan Mayfield, founder of Mayfield Renewables. And we've been doing these AMAs for, 4 years now, 4+ years. And it's always a pleasure to bring on our guests and talk about some topics that are really important to the industry. And today is a really good one. This is the financing aspect of it is obviously a critical part of the conversation. We at Mayfield, we are very focused on the engineering side. We are, doing consulting engineering, project engineering. We do education and training, things similar to this. We also have a lot of courses online. We're doing a summit, education summit in October. I'll show you a slide of that at the end. So really what we're going to talk about today is actually going to roll that into the education summit. It's kind of a preview, if you will, just a slice of what we're looking at doing there. But being able to have the engineering side talk to the financial side, that's a really big part of what we want to talk about today and really help bring some light to some of these things, some of these concepts and terms that maybe as the engineers in the room, we don't always think about. We definitely need to be considering them, but being able to connect those dots together to make sure that the project is completely bankable, that the project is going to be a success on all fronts. So today, joined by Jacob Betcher and Bill Shevlin. Jacob is the CEO here at Mayfield Renewables, and Bill is the principal at Mavericks Microgrids. So I'll let you both introduce yourselves, kind of, a little bit on your background, kind of your perspective on the topic at hand, and kind of, where you see kind of the importance of this. So Jacob, maybe we'll start with you.
Sure. Thanks, Ryan. I'm super excited to be on this. Ryan does this all the time. It's amazing watching Ryan get excited about all these topics, particularly, when we get into codes and standards or all of the expertise available. Personally, I have a background in engineering, got into business. I get really excited when we start talking about the combination of the two, when we're crossing between engineering and business, which is part of why I'm so excited about this particular presentation that we're doing. So we'll get into that. Bill's the expert on the finance side. I will be bringing in a little bit of perspective on what we do at Mayfield and how we get set up for, or help developers set up for, this financing piece. Bill, I'll let you take it from here.
Yeah, no, Ryan, appreciate being on the call, and Jacob, good as always to be talking to you. My name is Bill Shevlin. I've started out in the energy efficiency space, and then we were doing a lot of retrofit work for all types of different energy efficiency. And when you're doing energy efficiency, it has to create some kind of return for the customer to be able to finance it. That's kind of where I started. We started doing solar installation in 2008 because of the work that we were doing in the energy efficiency space already. And then we were primarily an EPC, so we did a lot of work with a lot of private clients all over the US. And then I always realized that the finance groups were doing what looked like a lot less work for a fair amount larger check. And so been focused more on the finance and development space side of the business since about 2018. We formed our company then, and then work with several different funding partners, tax equity groups, and debt providers to provide finance solutions in the space. We also work with a lot of developers in a co-development perspective to try to help with projects and bring to the table what's needed to be able to get those projects, fully to NTP funded and built and operating. So really appreciate the opportunity to speak to everybody.
Perfect. Thanks, guys. Yeah, and so I think this is, as we mentioned, a very big topic, important one. And so, let's jump into it. I know we have we have a number of slides here, and there's some real good meaty ones that I want to make sure that we have plenty of time to talk about. So microgrid financing and economics. And, one of the things, Jacob mentioned, my love of codes and standards. One of the things I don't necessarily have a love of is the financing side, to be quite honest. So I like to joke and say that this is the black magic part of it all. I can completely understand how the electrons move and all that kind of stuff, but you put a dollar sign in front of it, then it becomes just foreign to me. So really looking to Bill and Jacob to kind of help lead a lot of this, and I definitely have some questions as we're going along. So one of the things that we wanted to start off with was, what does bankable mean? And we, as an industry, we use bankable all the time, and I think it might, resonate for people as a whole. But I guess, I'm going to push this right out to you, Bill. In terms of bankable on a project, what does that mean to you when you're looking at this, and how do you start to evaluate that?
Sure. Yeah, I mean, I think those three main topics hit it. The one thing that really we didn't add to the slide was, a credit-worthy off-taker. So you have to have somebody that's always going to be able to pay the bill from an energy perspective, or pay for the project. But typically we look at a project to make sure that it if you're putting the money in, that money creates future value for the project from savings or revenue opportunity for the project, which leads to positive net value or present value. You have to always work with a bankable and reputable EPC that's got experience in the space and is going to be there through the construction of the project. Many times on larger projects, finance will require that the EPC be bondable, or be bonded, or the project have a bond to it to make sure that they can build the project. And then, obviously, tier one type equipment that has warranties, and that if we're doing a 20-year project as an example, that if that equipment doesn't last the entire 20 years, that you've got a replacement cost built into the overall economics of that project for that replacement value.
I'm curious on that. That kind of struck a chord with me a little bit, just given the times that we're in now and storage especially. I guess I'm curious, Bill, how you're evaluating that in terms of, tier one. I think we kind of can all get on board with what a tier one manufacturer would be. But even seems like some of the tier ones we see are maybe rolling back from, some of their product lines, or they just decide this wasn't the right move for us. So I guess, is there sort of like a way to hedge that, or, how are you thinking about that in terms of in a pretty new technology? I mean, it's not new per se, but it's rapidly changing. And so I guess I'm curious on how you evaluate that.
Yeah, I mean, and Ryan, that's a good question. I mean, when we went to go finance some projects a few years ago that had solar and storage, a lot of the finance groups and even tax equity groups were very cautious around it because it is kind of a new technology. Now, a lot of the finance groups want battery included because they understand that there's additional opportunities from a revenue perspective. But, typically, you obviously have to have a manufacturer warranty, but on many projects, you're also getting performance insurance and, product insurance on that equipment. And then, like I mentioned, when you're modeling the project, making sure that your O&M cost covers the replacement of that particular equipment. I think in the solar side, people are used to that from an inverter perspective. Most people, when they're modeling a replacement cost of inverter, they've got inverter replacement somewhere between year and 10 and 15. So battery is very similar. Battery typically has a degradation to it, so you lose a percentage of the capacity every single year, but most batteries may have a life cycle of 10 to 15 years, so you need to be able to factor in the replacement. And, some of that is really just a calculated estimate, because you look at what's the cost today, what do you think the cost is going to be in year 10 or 15, not just the cost of the battery, but the labor to replace that, the labor to remove the old battery. So those are some things that you have to factor in. But typically on a lot of projects, we do see, the insurance requirement, which can add like 1 to 3% cost of the overall project. But, it's kind of a belt and suspenders approach that is required a lot of times, both from finance, but also, could be required from a ownership perspective as well, even if they're paying cash.
So there's kind of two sides to this. One side is really that you're trying to make sure that you have a built out model that includes everything that's going to be needed to maintain that asset, including O&M, including replacement, and any other pieces. The other side to that is really, this is a risk analysis, right? So
Yep.
this is really looking at the equipment specifically. This is looking at the viability of the installer. This is looking at how good that model is for the financial analysis.
Yeah, and I think Jacob Mayfield does a really good job of like understanding the equipment side of it. The what we see a lot of times is developers bringing a project, or somebody bringing a project that has state of the art new storage technology, but it has not even commercially been deployed. That's an automatic out of the boat conversation typically with projects. But I know that Mayfield will look at those kind of things and understand what a commercialized technology is compared to something that hasn't been fully commercialized, or hasn't been in the market long enough that you can bank it, or you could get debt against that particular asset. So that is that's a very strong part of the overall pre-feasibility and looking at the project.
Yeah, and I think that's a perfect segue into what we wanted to talk about kind of at this point with feasibility studies. And so that is something that we are spending a lot of time on, something that we're really building up here internally within Mayfield. And so Jacob, I was going to kind of turn it over to you to let you kind of talk about feasibility studies and kind of that role of both the engineering and the financial side.
So we are primarily engineers. That's where we came from. That's what we've been doing for a number of years. A couple of years ago, we really decided that a lot of developers were coming to us with half-baked ideas, and we get partway through engineering and something would come up that was not really well defined in the feasibility process. And the biggest impact to this that we have seen is that the projects end up being 4 or 5 years instead of 18 months. And these are numbers that really make a huge difference on the viability of a project long term. So we started working into this feasibility piece and providing this as a tool. Our feasibility analysis really builds up a model that includes all of the engineering assets, all the resources, into something that has the entire plan built into it. This also, one thing I'll note is that the quality of our model really comes down to the quality of the inputs. So many things have to come from the developers, whether that's the utility rate structures, whatever credits are available, whatever pieces are available there, as well as all of the equipment specifications and details. Once we get that built into a model, we can really see and start to present these financial values, these resiliency values, things like that, that Bill and his team would need for assessing the financial viability and acquisitions, things like that of a project.
Yeah, and I think one of the things, Bill, you had mentioned during some of our planning calls was, this underperformance risk and being a significant being a significant risk without proper planning. And so I was curious on your side, we're going through and we're doing these. What are you looking for out of a feasibility study in order to properly analyze it?
Yeah, I think, Jacob hit a lot of it. It's inspirational versus executional, right? Like it says on the slide. And, you always need, from the finance side, we need an executable project. And what that means is that you have that utility information, you have a clear understanding of what the cost to build that project is, that you understand what the construction process is going to be, how long it's going to take to build that project, and what it takes to get an interconnect and permitting and fire permits and everything else that goes along with it. With microgrid type projects, you typically have multimodal power. So you may have solar, you may have storage, you may have genset, you may have fuel cell. So it's not just going down to the building department, getting an electrical permit, maybe getting a fire sign off. It's like you need all of those for all those different types of equipment. But you also need to make sure that that project can be executed and that it does, it serves the customer's needs, and that it's going to save the customer money, or that the savings of the project overall can cash flow the project. And that, that those systems, like we said, those systems are going to last the duration of that expected longevity of the project.
Yeah, and that's and that's one of the main goals there. And so there was a good question came in about overperformance risk, and I think that that's a valid question, a valid thing to be pointing out. We very often worry about underperformance, but if we are building something that's too big, there is that that same risk. And so I think the feasibility really is helping analyze that. I think as we've been doing more and more feasibility studies on the technical side, one of the really hard things is nailing down, what does that load look like? We're going to talk about, I think, more about, value of resiliency and all that kind of stuff. But knowing exactly what those loads look like in those different use cases, it's not an easy thing to answer, especially if the building is going to be used differently in an outage situation in a microgrid as it is maybe day to day. So it's definitely something that we're looking at as well in this feasibility studies. I do want to go backwards. Oh, you have something to add there, Bill?
Yeah, I was going to say, Ryan, just I think on that, like when, if you're modeling for resiliency, as an example, it's different than energy savings or different than peak shaving or something like that. And, where you're doing backup power resiliency, you really do need that interval data and some of the detailed information of the site to be able to model it correctly. And what we found is if the ownership group or the client is not willing to provide that information, it's not worth working on the project, because if they can't give you a detailed enough information to do the real feasibility work, you're not going to get to an executable project. It's not worth the waste of time going through an estimated resiliency plan or an estimated battery storage project if the customer can't even give you the basic information that they could actually pull, with a click of a button on a utility API or some other mechanism.
Sure, that makes sense. Before we get too far away from it, I'm going to go back. There was a question that came in right as we transitioned into this slide. But so, Bill, you had mentioned performance bonding. And so the question is, do you see payment performance bonding being required more frequently on microgrid projects? And so is that something that you're seeing?
Yeah, we do see that, so we do see that from a construction requirement perspective when the project is getting built, if you're using any kind of finance, because if you're, you've got, and typically that mostly takes place during the construction phase. You don't necessarily have that performance bond during the actual operation of the project, but we do typically see insurance policies in place during the operational side. So we usually will see, performance and contracting bond during the construction side. And then we do see sometimes bonds in the project to remove equipment at the end of the project. And more, especially on like small utility projects or large CNI projects, requirement to remove that equipment at the end, which the best way to guarantee that is some type of bond that, essentially ensures the cost of removal at the end of the project.
Perfect, thanks. And then I see another question comes asking about value, part of the value stack, and we're going to talk about that some more. So I'm going to hold on that question that came in. So I think we'll be able to kind of address that question here coming up. But let's kind of move on a little bit into equipment selection impacts. And, for us, this is, that connection of finance to engineering. Bill, you kind of mentioned these, up and coming, maybe not truly commercially available products. And, there's definitely some cool projects or products out there that, if it works right in the project, that would be great to use. But we've also seen historically systems come online that were maybe a little bit before their time, and unfortunately, doing beta testing in the field when that's really not the right place to be doing it. So we've definitely seen that in some of our own projects with storage and things previously. So I guess in that sense, and two, we also talked about, I think you had mentioned, Bill, just kind of these other resources that are out there. So I think a big part of this is just coming out of that feasibility study and looking at the equipment selection and kind of how it all ties together is an important aspect that we're constantly looking at and trying to connect those dots. Jacob, I'm not sure if you had others that you wanted to add on to that one.
I didn't specifically, but this is definitely a big piece of this early analysis, this feasibility analysis, is really getting into what the use case is, and the selection of assets really comes down to how you want to use them. I think, Bill, you might have some more insight. We were discussing this a little bit especially once we got outside of the solar and storage market, which is where we spend our most time.
Yep. I think, Jacob, the one thing that I see a lot in the market, both from a customer or client and developer perspective, is a misunderstanding of battery storage being used for backup power versus generator. And what I mean by that is, I actually had one earlier this week that, a customer wants to, hey, I want to add a battery because I want to be able to keep my power on all the time. Well, that could work if you've got enough solar at the site and you got enough to be able to charge that and discharge it. And depending on the load of the site, and you need all that interval data to, calculate that. But using straight battery storage as backup power is fairly expensive compared to a genset, as an example. And then if a customer wants that resiliency factor, how much of the building do they want to cover and for how long? Do they want to cover their critical infrastructure, like maybe an IT closet or an IT room or the air conditioner or, some type of electronics, or do they want to power their entire facility? Those are vastly different scenarios, and those are typically not projects where you save money. Those are projects that are more resiliency related. But again, I see a lot of requests from people that want to, provide 100% power for their site from a battery, and typically that's not feasible. You need some type of combination of, battery and genset to be able to actually provide that power. And then if you need, if you're on a data center site or a critical site that needs 24/7, typically it's a combination of maybe gas genset and diesel genset, depending on the guaranteed uptime of that facility that's needed.
Yeah, and I think this gets right back into that feasibility analysis of right sizing the system for both the finance side as well as the resiliency side. It's very important. And with our experience, it really is typically enlightening to our clients once we build out these models as far as what it is that we can back up, with a system as proposed.
Yeah.
Awesome. Yeah, so let's move on into kind of some of this value stacking. And I know, Jacob, you had some things to kind of address on this one. So, just talking about with our systems, with our microgrid systems, when we talk about microgrids, very often we are focused on that resiliency focused. I know that that's where my mind personally goes a lot, but there's a lot of this other value stacking that can go along with the storage and the system itself, and so it really helps just make sure that the system is as financially sound as possible. So I know this is something that you've thought about, Jacob, and I think that'd be great to have you kind of hear your take on the kind of this value stacking aspect.
Yeah, value stacking is a term that's being tossed around the industry a lot right now, particularly when you get to batteries and what you're going to do with them. This is an example that has some peak demand, some demand response, and this is stacking a couple of different things. There are 10 to 20 different things you can start leveraging from a battery depending on what's available in your market. This we just have this as a slide showing that it's doing more than one thing, really. And I think Bill can probably lean in a little bit more on just how many types of things you can value stack to really create the value in these systems that goes well outside or well beyond the resiliency play.
Yeah, I think, Jacob, I think most people, do, when they're looking at batteries, they do think in terms of like demand charge management and demand response, but as you know, like in California, if you're under NEM 3, you've got to be able to size that battery so that you're not exporting that power. But, it's a combination of not exporting the power, being able to do some demand response or peak shaving with that battery and then plug it into a demand response market. And then, like we were talking earlier, in some markets, we have seen additional revenue streams for batteries in key markets. Like New York has their own version of a demand response. There's different grid service programs that are coming out in different utility sectors. And so it's critical for the developer to understand those local incentives or those local programs that are available from the utility from a revenue perspective. And when you're modeling it, you've got to make sure again that you're taking care of the customer's load profile and not trying to create a revenue stream when the battery should be used by the site. So that goes back to having the correct data and having the correct feasibility to understand what those loads are so that when that battery is available for demand response in this example, that it is actually available for that demand response and not being used by the site, which means that you've modeled it correctly.
Right. This does show the detail required to actually model this, the energy use, the energy savings, and these different demands on the system overall. These are sub-day modeling requirements. Getting back to Bill, your 15-minute interval data to really analyze what you're going to be using and what's going to be available for these different programs.
Perfect. So kind of jumping into some of those programs and start talking about some of the financial modeling considerations. Bill, this is one that as we were preparing for, there's a lot to this, and so I want to make sure that we give this slide and these topics ample time to get into, and looking at some of the questions that came in from our poll and things like that. I think this will really help, I think, answer a lot of those questions just in terms around what the modeling around microgrids and kind of what some of these considerations are. So I'll kind of kick it over to you. And one of the things as we're going through, we'll be trying to talk about the naming conventions and kind of what they mean and how they kind of come into play. But Bill, I'd love to kind of hear how you're approaching this, when you're looking at it, and we were talking about kind of your approach on it, in terms of when do you put in these different credits and things like that into the model to be able to make sure that you're accurately looking at it.
Yep. Yeah, I know. Thanks, Ryan. So when we look at a project, we always look at an unlevered return or cash on cash first. You know, and as an example, if a project costs $100,000 and it's only going to create $100,000 worth of savings, cash on cash perspective, that's not a very good return, especially if it's a 20-year project. You put $100,000 in and you save you save $100,000 over 20 years. That's probably not a good investment. You could, potentially make that thing pay for itself by utilizing some of the different incentives and tax credits, but you want a project to be able to stand on its own from a cash flow perspective without the incentives. As we know, the Senate and the House are going back and forth on some of the tax credits, and we believe that we will have continuing tax credits, but we don't know exactly what those are going to be until after the legislation gets passed. But, based on that, we model on a cash on cash basis first, and then we layer in the different tax credits. And so, the usual that people are used to are the investment tax credits. Those are standard tax credits that have been around the solar industry since 2008 or earlier. Depending on the type of the project, you can also get into production tax credits. Those are a little bit narrower of a window. They do provide incentive that are not directly the same as an investment tax credit, but they work in a similar mechanism to a production tax credit. And then we've got new market tax credits. There's other types of maybe local tax credits or incentives that take place. And then on projects where you have carbon capture or associated different technologies, you've got 45Q, which is an additional tax credit. So, all of those different tax credits can really increase the return of a project and open the finance options of a project. But you really have to understand how they work, how they layer in with the overall return of the project. And, you can't make a project work on just credits and incentives. It's almost impossible. So looking at a project on its own from a cash flow perspective is really important. And, that's where having a strong feasibility study comes into play, because if you've got the understanding of the project, what the utilities cost, what the thing is going to cost to build, what the potential cash flow of the project is, then you layer in those other, incentives. And then, like you've got, like regional carbon markets, those could be renewable energy credits. They could actually be carbon credits in some specific markets. And then you've got state and local grants. Like in California, as an example, for battery storage, you have the self-generation incentive. That incentive is a limited pool. It's not unlimited. And a lot of times I see developers thinking that money is going to be available forever in unlimited amounts. It's not. There are different programs. I know New York has its own program for battery storage. Connecticut has its own program for battery storage. So there are incentives and grants from the utilities that are market specific. Sometimes they're based on capacity. Sometimes they're based on kWh. There's a lot of different variables. And so, from a developer perspective, understanding those different incentives that are available and then being able to layer them in can really help pay for the project. But the other thing to keep in mind is that typically the tax credits, all the different types of tax credits and the grants and incentives typically come in after the project is built. That's usually the way that the cash flow works. So you've got to be able to pay for the development of that project, build the project, get the project to operational or close to operational to be able to monetize some of those other incentives and grants. That's one of the mistakes that I see a lot of developers making, thinking that they can get that money in on the front side, and that's basically free equity. And that's the market typically won't work that way. And then on the implementation side, we already talked about it, but having a qualified EPC that's bondable, and then when you're utilizing different technologies, sometimes you can stack those credits or incentives, but you have to be able to understand when you can and when you can't, because if you're relying on stacking some of those credits and you really can't, then you kind of shot yourself in the foot from a finance or a viability perspective.
Yeah, absolutely. Understanding kind of what those are and how we can actually use them and when to use them. That was something we were talking about earlier just a few minutes ago. And when we're preparing, you were saying, Bill, about the timing of those tax credits. I think that's a very important thing that people understand. Like, you might have to wait till the end of the project, and if this project takes multiple, sometimes years, that can really put a damper on what you thought was your cash flow.
Yep.
Couple questions that came in. One was a pre-submitted question, and I want to just kind of talk about that. And there was one that came in earlier from the poll that I kind of want to incorporate into the whole thing too. But the pre-submitted question was asking about what are some of the key financial indicators that commercial businesses want to evaluate to make a go, no-go decision. And I think you touched on it a little bit, Bill, where you gave the example of, if you're going to save the same amount of money that you put into the project over 20 years, time value money, lots of things in there, and it's probably not the investment you want to make. There's probably other things, and maybe there's ancillary benefits, things like that. So maybe you can justify it, but maybe if it's a pure financial thing. So I guess, what are some of those, like, just first conversation, go, no go kind of things that you're looking for to answer to even know, like, a lot like, are we using this brand new technology from the MIT lab that hasn't been put into commercial use? Are there other things that you're looking at to kind of make that decision?
Yeah, I think, Ryan, so I go back to my energy efficiency days, right? When we were doing a lot of energy efficiency, sometimes we were working with clients, they paid for it because it gave a certain return. It was a 2-year payback or a 3-year payback or a 4-year payback. That payback was typically cash on cash, meaning that if we put in $100,000, it generated $400,000 worth of savings over a 4-year period of time, and the CFO would sign off on that because, hey, I can make this investment. The technology that you're putting in is going to last me 10 years. So I saved $1 million over that 10-year period of time, and I paid it off in 4 years. So one is, if the client is paying for it, what's their expectation that their money is getting made back, and how quickly are they getting made back? That's a primary indicator. From a finance perspective, if you're financing it on a loan or debt, does the savings of the project enable the servicing of that debt, the payback of that debt, and the interest of that debt? If you're financing it with a third party, what's the expected return or the hurdle rate that the finance group needs? Typically, finance might want a 10% unlevered return or a 15% unlevered return. Maybe they're a tax equity group and they're expecting a certain percentage return on the tax credit. So understanding the cost of the project, what the savings of that project is, that's feasibility work, right? You get that feasibility work done, it tells you what the savings is going to be and what the capital cost is going to be. And then you've got your options that you present to the client or your finance partner or the bank, or however you may be funding that particular project.
Yeah, perfect. Another question that came in was, what commercial sectors are microgrids penciling for right now? And so I'm curious if you have just overall on that, Bill, of what you're seeing. We hear a lot of interest and talk, and we're taking part of an event in July in Bend. The Great Transformation is really focused around data centers, and so you just kind of curious if there are others that you're seeing that are this is a great solution for, and people are just coming to wholeheartedly.
It depends quite a bit on the technology. If we're talking solar and storage, that's a different conversation than solar and storage and generator, and then what type of generator, because the type of generator that you choose has different O&M costs and different operational costs from a gas perspective. Is it a fuel cell? So part of it is the, the cost of the project and the operational cost of that project or the technologies that you're using. But, in a lot of markets, we see microgrids paying for themselves. Probably not going to be Oklahoma. Probably not going to be the Midwest where the cost of power is 4, 5, 6 cents. But, California market, in Arizona, we see it penciling quite a bit. Actually, in some cases in Texas, Northeast is a very strong market for microgrids. But, generally, again, if it is a microgrid, it's a combination of the savings or the paying for itself, the project paying for itself, but also that resiliency factor. And again, depending on the client's resiliency requirements, if, just like here in California as an example, let's take a hotel. If you have battery storage and a solar array and the power goes down, but the office can stay online and maybe the elevators and some of the critical infrastructure can stay online when the power is down, that's a value to the hotel. That's an add value aside from the savings of the particular project. So microgrids in the high cost power markets, they almost always pay for themselves from a savings perspective. But again, you do need to factor in that resiliency factor and what is the client looking for as far as being able to stay online and resilient. So those are kind of the primary drivers. Is one, what's the technology? Two, always look for the more expensive markets, and then, the facilities that need to stay online. It's not necessarily a question of savings, but operational savings. Like a grocery store is an example. I know that HEB is a chain that's adopted like gas genset backup, because if their power goes down, they're losing refrigerated food almost immediately. You're talking about, potentially hundreds of thousands of dollars worth of loss within hours. So keeping some of that critical infrastructure up and running is more important than the energy savings. Coincidentally enough, there is still energy savings in that scenario. But that's kind of what we see, Ryan.
Perfect. And that actually gets right into, and I think you might have kind of answered the question already, but somebody asked earlier, and I was putting a pin in it around these reducing risk premiums. So insurance premiums being, you're reducing your risk, you're reducing some of the example you gave around the grocery store. That's a great reduction of risk in terms of spoiled food and insurance premium. I guess real quickly, because I want to make sure that we give ourselves enough time on the sample project, but have you been able to incorporate that, or have you seen that kind of like premiums being actually reduced because of reduced risk as well?
Haven't necessarily seen premiums reduced, but we've had a lot of conversations with clients around loss of inventory or loss of downtime related. And when we're giving a presentation, if we've done our job right and gathered the information, we can come back to the customer and say, here's how much you're going to save on energy overall, but this is how much you're going to save in inventory loss or down employee time, or whatever that factor can be, because a lot of that data from a grid reliability perspective is available online. So you can look at a lot of different data and see how often was the power off in their particular market. And if you're talking to let's say a wastewater treatment plant, power goes down for a wastewater treatment plant, all of a sudden you could have environmental liabilities that incur because now you're not processing sewage and you're just dumping it.
Right.
So, doing your diligence on the front side and actually understanding, if there is resiliency factors in that, what's the actual cost of that resiliency factor? I think that you would see some insurance premium savings, but that's going to be, a fairly large client that's got a fairly sophisticated operation, working with them, and then they're working with their insurance carrier to get that. But it's more of that, what's their reduction of loss by being able to keep their power on.
Yeah. That's all good points. And I would just say like little crystal ball looking there too, because the forward thinking on the loss of utility power is changing rapidly in some of these areas.
I want to make one more note on that. When we get into our financial modeling of these systems on the feasibility side, often people don't really think much about that balancing act between resiliency and using this as a financial asset. And making those decisions during that financial or that feasibility analysis is an important piece. Is how much capacity are you going to reserve for resiliency versus using in this financial sense for the microgrid itself. So
Yeah.
Perfect. Okay, I'm going to jump into this. We do have kind of a couple sides on this sample project, and so Bill, this was really something that you brought to the table. So I want to give the floor to you to preface it a little bit, just kind of really wanting to I guess ask the question, what are the financial metrics? If there's the top financial metrics that are really important for financiers, kind of, it's an internal rate of return, is it the levelized cost of energy? What are those things? That what matters to the financiers? And then after this, we're hopefully we'll have time because I know we have a lot to say, but just kind of talk about other mechanisms other than grants, because I know a lot of, especially here in the Northwest, we see a lot of grant funded projects. So I know we have a slide on that. So I'm just kind of prefacing this conversation there.
Yeah, so this particular project was it was actually a off-grid microgrid with CO2 capture for a oil and gas production facility. So actually capturing CO2 at the well site, as well as providing power to the site. So it's a combination of solar storage and generator to be able to get the power to their site, but adding that CO2 capture. And so, the unlevered return was I think it was like 15% or just under 15%, which means that it's cash on cash, right? So the total capital of the project was $23.8 million. And the cash flow of that project from an offtake perspective, so we were selling power to the site. We're also monetizing the 45Q credit because we're capturing CO2 at the site. We were able to, finance that for the project. The other thing that we did that was a little bit unique with that particular project was we actually marked up the tax credit to 1.35. And the way that we did that is that the project had a fairly high fair market value of $27 million. The one thing that most developers don't understand, and a lot of people don't actually understand on the ITC side, is that if you are holding a project from an operational perspective, the ITC, the depreciation, and a lot of the economic drivers are actually based on the fair market value of the project. You have to get a third party to do the appraisal on that project. The fair market value is driven on the bankability of the project, all the other things we talked about, the bankability, as well as the revenue, what the long-term offtake is of the project. It's a third-party appraisal that essentially looks at that project. They give you the fair market value, and then the ITC is based on that. So what that means is, the ITC was based on $27 million. The ITC investor put in about $14 million overall. And then, our debt was 11.9 on that particular project. That allowed us to get additional development fees on the backside, because we got 14 million on the one side, we got 11.9. And then it has a debt service coverage ratio of 2.41, very strong debt service coverage ratio. I saw a question on the debt service coverage ratio. Typically in microgrids, solar storage, maybe genset combination, most of the debt providers that we work with want to see 1.3, 1.35 debt service coverage ratio or better. And debt service coverage ratio is basically, it's the ratio of the income compared to the debt, or the required debt payment on the project. So the excess cash flow essentially to cover that debt. And so, that was kind of the kind of high level overview. And, from a levered perspective, we had about a 21.4% levered return. So that was our return after the debt was, on the project and what the cash flow of the project was overall.
Excellent. I'm just gonna move in. I think there's another slide on this one, so I want to make sure that we have a minute to talk about that as well. If there's more
Yeah,
points there.
so this,
Yeah, I think I was just going to say, it seems like this is highlighting that question I asked earlier, some of those key things that financiers are looking for in terms of those the rate of return and the other items that are
yep,
super important.
yep. So this, so this slide, Ryan, kind of shows what I talked about earlier is the ITC investor, putting close to $15 million. And, they received the ITC, they received an investment tax credit benefit of almost $11 million. What that means is the investor put in the 14.7 on the project. They received basically direct write-off, almost $11 million on their taxes. They don't know that $11 million. First year depreciation benefit that they received, net benefit to them was $6 million on the project. So they actually got $16 million in direct benefit from a tax perspective on a $14 million investment. So, they got 160+% return. They also got some additional revenue benefit from the project for the first 6 years of the project. So from an investment perspective, not only did they save money on their taxes, but they also received income return on what would normally be a tax payment. And then the project is expected to sell at the end of 7 years when that tax equity investor is what's known as flips out. So the tax equity investor has 6 years to be able, well, they've got 5-year accelerated depreciation, but typically they stay in the project 6 years from a tax perspective. Once they're out of the project, that project is expected to sell at about a $47 million value.
So in this situation, that rate of return, I mean, I guess what would be that's a term that I'm familiar with, the internal rate of return, what's a good metric for you there?
So for the tax equity investor, so for our investor group, the rate of return on the project overall unlevered was 14%. It's very strong investment. There was a little bit more risk on the project because the off-taker was a fairly new entity. Oil and gas company, oil and gas can be volatile. So, we've got a fair amount of insurance on the project. There's also some clauses within the contract that allows us to securitize assets on their end if they fail to pay. We don't want to take over an oil field operation, but we've got access to the asset if needed, if anything ever went south.
Got it. Okay. Well, want to make sure that, so we're getting close to the top of the hour, so have just a couple more here, but one of these, so I think this is going to touch on that last question I asked on, other than grant opportunities or funding mechanisms. So talk to us a little bit about special project vehicle and kind of, what these different vehicles are and how developers and financiers can take advantage of these.
Sure. Yeah. I mean, so a lot of times you'll hear the term SPV or SPE, same thing. Essentially what it is setting up the project under a limited liability company. So project gets set up into a limited liability company, and that allows you to do that fair market value on the project. It allows investors, it allows debt against that project at the project level. It allows the tax equity to come in through that project. And, typically under that SPV scenario, the usual mechanism is tax equity flip. Tax equity flip is kind of like what we just showed there. Tax equity investor comes into the project and then they exit out of the project in year 6 or 7. The one thing that most people don't understand is that tax credit money does not come in until the end of the project or near the end of the project. From a flip perspective, if you're doing a tax equity transfer, that money doesn't come in until the bulk of that money doesn't come in until after the project is online or it's reached commercial operation date. And, essentially you've filed the correct returns with the IRS, you registered the tax credit, you sell that tax credit on a discounted face value under that transfer scenario, and then you receive that money. you may not receive that money for 60 to 90 days after the project is completed. So project developers need to understand that they need to be able to carry the cash of that cost, or the construction cost, until that tax credit comes back in through that transfer mechanism. Or if they're doing this flip structure, that the bulk of that money doesn't come in until towards the end of the construction, and the bulk of it coming in at the end of the construction. The other scenario is working with a private equity group, where the private equity group is using probably a combination of their equity, maybe balance sheet, and maybe they're even providing debt or a line of capital to be able to finance that project. And then you've got the model of developer owned and operated. Typically with developer owned and operated, it's a developer that's been around a while. They've got a balance sheet. They may have an equity partner. They typically have some finance partners that will back them in one way or another. So when you say developer owned and operated, it's typically not just the developer. It's maybe a group of the developer and tax equity and maybe, debt providers in that combination. So there's a few different, ownership scenarios there, and finance scenarios there, Ryan, but, primarily they take place underneath that SPV or that LLC type entity that allows you to develop the project. The other thing that we do see a lot, Ryan, in developers that maybe develop a project and they don't want to own and operate the project, they just want to sell the project. If they have put that project into an LLC and they have all the proper documentation dedicated to that LLC, it makes that project easier from a sales perspective, because somebody can come in and purchase that asset. Because once the developer has put the PPA, the engineering, all the different costs into that LLC, a developer that maybe finances their own, or an equity group or a finance group, can come in and acquire that LLC. And that means that the developer, is essentially making markup on the development of that project and the money that they've spent into the project. The one thing that we did not cover, Ryan, is, the development cost of these projects can be significant, because a project may take 6 months, it may take 2 or 3 years. And
Right.
The developer needs to be able to put in the money for the pre-engineering or the feasibility study. They may need to, if they don't have PPA documents and they don't have some of the legal documents, they need to be able to pay an attorney to be able to structure all those documents. They probably need to do an interconnect agreement. They may need permitting. The closer you can get it to an NTP perspective from a developer perspective, the more valuable that project becomes, to be able to finance or sell that project.
Yeah, definitely a lot more that we could definitely get into. And I think that's a good segue. We're getting right at the top of the hour. So I really appreciate Bill and Jacob, your time and expertise here. And just to, reiterate, this is a topic that we're going to be covering on our education summit that is happening in October in Seattle this year. And we actually have, early bird rates through end of June. So I think July 1st is when those go away. So if you're interested in that, I highly encourage you to take a look at that and join us up in Seattle. And then I just wanted to also make sure that we get our folks, our panelists, information up here. We, of course, you can reach out to us at Mayfield Renewables anytime, questions, comments, things like that. I do, really appreciate, Bill, all of the wonderful expertise, Jacob, your insights into the topic, and just thank you very much. And I appreciate everybody out in the audience for joining today. So thank you very much.
Yeah.
Thanks, everyone.
Thank you.
Yep.
It's been great.